Welcome back. Last time we talked about some basic limits, what they meant, how to do them. Today we're going to show some examples of more complicated limits, some a little bit more algebra manipulation to figure out. Okay, so far we focused on simple algebra, factor cancel. These following problems will be more complicated, but once you recognize what kind of problem you have, they'll be easier to do in the future. There's only a few types of problems you're going to see. So here I see a fraction. Okay, always try to plug it straight in first. So I have 1/4 plus negative 1/4 over 4 plus negative 4. So that's the 0 over 0, the thing I don't want to get. That means I have more work to do. So let's combine this all together on top to make one fraction. Common denominator is 4 and an x. This one needed the x. This one needed the 4. Times, instead of dividing by 4 plus x, I'm going to multiply by 1 over 4 plus x. Now look what happens. All this on top and this on bottom are really the same binomial, so they cancel out. So that's 1 over 4x. Now I can plug in whatever I needed to plug in. I'll get 1 over 4 times negative 4, which is negative 1/16. So I still canceled something out, I just couldn't factor. I had to do a common denominator here. Let's see some other examples. Okay, if I plug in the 9, I'm going to get square root of 9 minus 3 over 9 minus 9, which is 0 over 0. It's that indeterminate form that we don't like. We don't know whether it means 0 or a number or undefined. So, if this was x squared minus 9, if it was x squared minus 9, you would factor as x plus 3 and x minus 3. How did you get the x and the 3? Well, you just took the square root of each side. Using that same logic, I can treat x minus 9 as the square root of x plus 3 and the square root of x minus 3. It's the same pattern. Double check it if you want to. That's x minus 3 square root of x plus 3 square root of x will cancel. Minus 9. On top, I still have square root of x minus 3. But notice now, I can cancel. So now I just have 1 over the square root of x plus 3. That's 1 over the square root of 9 plus 3. That's 1/6. So I did factor and cancel. It's just different than what you're used to seeing. Absolute value problems are a little bit tricky. I know it's kind of hard to see, but this says 2 minus, this says 2 plus, and this says 2. So 2 from the left side, 2 from the right side, and then just overall the limit of 2. But let's stop and think about this. I have something over itself, the same thing divided by the same thing. No matter what number I plug in that's bigger or that's less than 2, 1, 0, negative 1, negative 2, I'm going to get the same number on top and bottom, with one exception. The top number is always going to be positive. If I plug in a number less than 2 to the left of 2, like 1, I'm always going to get a negative on the bottom. So I'm going to get a number on top and the same number on bottom, except the top is going to be in absolute value bars, which means that the top is going to be positive. But in this case, because I'm going a number less than 2, I'm going to get a negative on the bottom. Well, what happens if you have the same number on top and bottom, but one's positive and one's negative? You get negative 1. Now let's compare that to this one. If I pick any number to the right of 2, like 3 or 4 or 5, I'm going to get the same thing on top and bottom. So I'm going to get the same number on top that I do on bottom. The number on top is always going to be positive because it's an absolute value. If I pick a number to the right of 2, bigger than 2, 3, 4, 5, 6, 7, any number that's bigger than 2, that's also going to give me a positive number. So here I get the same number over itself and both of them are positive. That's going to reduce down to 1. Because that's negative 1 and that's positive 1, what's my limit at 2? It doesn't exist. You don't get the same thing on both sides. If you saw a graph of it, it would make more sense. So if you have a graph of this thing, here's the point 2. Okay? I cannot plug in 2. If I plug in the point 2, I'm going to get a hole. But everything to the left of 2 is -1, everything to the right of 2 is +1, it's very obvious to see that that graph doesn't have a limit at that spot. They go to different places. Let's try one more. This is the tricky one. If you plug in 0, on top you get square root of 5 minus square root of 5 over 0, which is 0 over 0. That makes me sad. It's an indeterminate form. I don't know what the answer is. I can't factor anything. So I'm going to multiply the top and bottom of this thing by the conjugate. The conjugate is just the same thing with the opposite sign in the middle. You should remember this from the difference quotient section. I'm going to FOIL out the top. Well, the first 2 is going to give me x plus 5. When I do the outside and the inside, I get the same thing, except one's positive and one's negative, so they'll cancel. And then the last 2, positive times a negative is a -5. And on the bottom, it's x square root of x plus 5 plus square root of 5 in parentheses. Well, let's look at what happens here. These 2 things are going to cancel. And then these 2 things are going to cancel after those go. So everything on top cancel. I still need something there. It's a 1. On bottom, I got square root of x plus 5 plus square root of 5. Now, what am I plugging in? I'm plugging in 0. So if I plug in x equals 0 right here, I get 1 over the square root of 5 plus square root of 5. That's 1 over 2 square root of 5. Okay? If you want to rationalize that denominator, which you don't really have to, but if you want to, I'm going to take 1 over 2 square root of 5, and I'm going to multiply top and bottom by the square root of 5. That gives me a square root of 5 on top. On bottom, these 2 things will go together to give you 5 times the 2 that was already out there is 10. Either of those 2 answers is acceptable. Eventually, we're going to have to rationalize our denominator, so we practiced it there. So these are the types of limit problems that you can see that are more difficult than what we did last time. But once you see them, either factor in some way that you're not used to, or look at the absolute values, or do the conjugate, or make a common denominator. It's all done the same way.